these have kind of been known for quite some time, that you get this internally generated so-called decadal variability of the climate system. What's making this current one compelling, obviously, is we're in the middle of it, and we're in a period of great scrutiny in terms of climate change, and so there is this feeling that, oh well, each year should be warmer than the preceding year, or we don't have any global warming, and people have this impression that global warming is this kind of relentless kind of march upward in temperature year by year, and it doesn't work that way. There's a lot of year-to-year fluctuations and a lot of slower fluctuations of the system that go on these kind of decadal time scales.
Right. So the argument is made that perhaps our models or expectations of climate warming might be a little bit on the high side. How do you
Well, yeah.
understand?
So one interpretation of this is when you look at the simulations that we've traditionally done to simulate climate change, we usually go back to like the year 1850 or sometime in the 1800s, and you start increasing greenhouse gases as it was observed, starting in the year 1850 and going up right up through present day, and then you have various scenarios of what could happen in the future, and so you have this kind of the model is generating its own climate response based on the forcings or these factors you give it in terms of greenhouse gas changes, ozone changes, volcanoes going off when they went off, changes in visible air pollution, as much as we can determine from observations, geographical patterns of air pollution over time. And so then you go from the present day into the future, and you really have no knowledge of the state of the climate system. You just know in the model what the model response was to these forcing factors or these things that affect the climate. And when you look at those kinds of things and you average across all the different models, you see just a kind of a temperature increase that goes right on through the early 2000s. But of course, the observations showed this kind of a flattening off of the warming. And so the reaction is, oh, well, the models are all wrong. They must be too sensitive. They're giving more warming than what we observe. But of course, the models are multiple simulations from multiple models, and when you average them all together, by definition, you're averaging out any kind of internally generated variability, and that's by
Right.
design. What you want to do is you want to see what the model's reaction is to these external forcing factors like increasing greenhouse gases. So we've just recently, as a community, started doing something quite new and different in this regard, is we'll take a fully coupled climate model that we've used for these so-called projections, and we will start the model out with a certain observed climate state. In other words, we'll initialize the whole model with as many observations we can find to give the model a starting point from a certain observed state, and then run the model forward in time with all the external factors changing as we see in the observations or projected into the future. And these are called, this new area of climate science is called decadal climate prediction. And it's kind of like numerical weather prediction that's been done for 50 or 60 years now, where you initialize an atmospheric model with observations, say for today, and then you run the model forward, integrate it forward in time for the next 5 or 6 days to see how the weather is going to evolve over the next 5 or 6 days. It's kind of the same idea, but you take a full climate model with the components of atmosphere, ocean, land, and sea ice. You initialize the whole climate model with observations of, say, this year, and then you run the whole climate model forward for, say, 10 years to see if you can track the time evolution of the regional statistics of climate as a function of time. So it's quite a bit different kind of conceptually from what we've done before, where we just are running these models, started in 1850, and they're generating their own kind of climates, and then they kind of go into the future with projections from these various scenarios. So it's kind of a new methodology, and we've only really been doing this for as a community for about the last 5 or 7 years. A couple of groups have been experimenting for maybe the last 10 years, but these kind of a data set of a lot of these different models doing these initialized predictions, as we call these initialized predictions, because you're starting the model or initializing the model with an observed state. The question, of course, is if we would have had this methodology in the 1990s, would we have been able to forecast or predict the onset of the hiatus that we're in now? And indications are from a couple of different studies that by using the observations for those time periods, say in the mid-90s, and running the models forward, say from 1995 to 2005, you can actually see in the initialized predictions that the temperatures kind of tail off, and the uninitialized or the kind of routinely run models just keep increasing. So you can actually see that there is some skill in terms of predicting this kind of leveling off of temperatures in terms of the global average. So these same models seem to indicate that we're going to come out of the hiatus in the next 3 or 4 years.
Oh.
So we'll see how that works out.
Is that like the next El Nino event, or what is it? What's the
Yeah,
first?
and this is kind of, this is really an active science
Sure.
question right now. But one of the ideas is that these hiatus periods and accelerated warming periods can sometimes be triggered by an El Nino or a La Nina event. So, for example, the current hiatus period we're in now, we had the real big El Nino event from 97, 98. We had a big 2-year La Nina event from in the late 90s all the way to 2000, and it's like we never really came back out of that. And the big mid-70s shift, which was an accelerated warming period, started with an El Nino event in 1976, and that seemed to flip the system into another state. So this is a possibility that's being studied, that there may be this interaction between these things that are happening on the year-to-year time scale that can somehow trigger or initiate these kind of slower fluctuations of the system. So these are all really interesting science questions, because these things that are going on in the Pacific are associated with something called either the Pacific Decadal Oscillation, or PDO, or the Interdecadal Pacific Oscillation, or IPO, depending on which community you're looking at. They're basically the same phenomenon, but it's these very slow fluctuations of sea surface temperatures across the entire Pacific that have this kind of pattern. Keep getting this phone call. There's a lot of evidence that looks like these patterns of sea surface temperatures in the Pacific are associated with larger scale atmosphere and oceanic circulation changes that are internally generated, they're naturally occurring, that can produce these slow decadal fluctuations in the system.